So, in today's class, we discuss about this arithmetic progressions. So, in this, first we discuss about sequence. What is the definition of a sequence and how to write a terms? If nth term will be given, then how to write the first term, second term, third term, fourth term. And after completion of that, we discuss about the definition of arithmetic progression. What is the definition? And how to write arithmetic progression, how to identify arithmetic progression. Then what is the general term like nth term of arithmetic progression, and how to find first n terms of arithmetic progression. Okay, so these are all the topics in the chapter. So first we discuss about sequence. So this is the main. So without knowing sequence, we can't define that arithmetic progression also. Okay. So here, example I am taking 1, 2, 3, 4, 5 and etc. This is one example. And one more example is 2, 4, 6, 8 to 10 and etc. And if we take one more example, that can be written as 1, 3, 5, 7, 9 and etc. So not only these three examples, we can write n number of examples. But what is the meaning of this? Here, generally we know very well about this natural numbers, right? And these are even numbers, these are odd numbers. But what is the meaning of this? We can write all like this, but how to define a sequence? Generally, a sequence is an arrangement of n numbers in a definite order according to some rule. Okay, I am writing here. A sequence is an arrangement of numbers in a definite order according to some rule. So this is actual definition, but what is the meaning of that? Say here we are taking 1, 2, 3, 4, 5 and etc. right? Means all those numbers in definite order. So we arrange it in definite order, correct? So from means like small value to bigger value. What is the meaning of that? Ascending order, na? Ascending order means down to up. Descending means up to down. But always we are taking down to up only. Means climbing a tree or like that, etc., etc. Okay. And generally, there is one symbolic form for the sequence. And there is one general form also, standard form for that. That can be written as A1, A2, A3, A4 and etc. And this sequence is denoted by like this. So here n equal to 1 to how many values are there means infinite number of values. Na? Actually it is not required, but we will study in PUC, not now. It is not required, but just you know about that, how to write the sequence form. And in some cases, an equal to 2 power n plus 3 will be given. And how they will be asking that question? Write the first 3 terms, write first 5 terms, write first 10 terms. So they will be asking like that. Okay. In that case, if you want first 3 terms, just we substitute n equal to 1. If n equal to 1, we get a1, and 2 power n plus 1 means n equal to 1. So 2 power 1 is 2, 2 plus 3 equal to 5. If you want second term, that is a2. So 2 square plus 3, 4 plus 3, 7. If you want third term, n equal to 3. So that is a3 equal to 2 power 3 plus 3. 2 power 3 means 8, 2 cube, right? 8 plus 3 equal to 11. So we can write like that. Okay. So I'll explain a few more examples in this. Take a question and answer. So this is actual definition and exact definition of a sequence. Okay. Okay. Now this is the first question. Write the first 3 terms in each of the sequence defined by the following. In that first sub question, an equal to 3n plus 2. Now we write first three terms, right? So first write given value. What is that? Given that an equal to 3n plus 2. So first three terms means what is that? A1, A2, A3. Now how to find A1 value? If we substitute n equal to 1, then we get A1, correct? So 3 into 1 plus 2. So 3 into 1 is 3. So 3 plus 2 equal to how much? 5. And if you want second term, just substitute n equal to 2. Now n means 2, right? And here 3 into 2 plus 2. 3 into 2 is 6. 6 plus 2 equal to 8. And coming to third one, means we want first three terms. Again substitute n equal to 3. We get A3. That is 3 into 3 plus 2. So 3 into 3 is 9. 9 plus 2 equal to 11. So that is the answer for that question. Okay, now this is the second sub question. What is the given value here? An equal to n square plus 1. An equal to n square plus 1. Again, we find first three terms. Then how to find that? If you write n equal to 1, we get first term, right? That is 1 square root plus 1. So 1 square can be written as 1. 1 plus 1 equal to 2. And if you write n equal to 2, we get second term. So n equal to 2 means 2 square root plus 1. So 2 square can be written as 4. 4 plus 1 equal to 5. And again we want third term. For that substitute n equal to 3. So A3 equal to 3 square plus 1. 3 square means 9. So 9 plus 1 equal to 10. So these are the first three terms. Now this is the third one. So here also just we write first three terms, right? First write given value. What is that? An equal to 3n plus 5 into n plus 2. That is product of two terms, right? So if n equal to 1, then A1 can be written as 3 into 1 plus 5, right? And here it is 1 plus 2. Now, why? Because n equal to 1. Then 3 into 1 is 3. 3 plus 5 is 8 into 1 plus 2 is 3. Then 8 into 3 is 24. And if you substitute n equal to 2, we get second term, right? So how to write it? 3 into 2 plus 5 into n plus 2 means what is the value of n? That is 2. So 3 into 2, 6, 6 plus 5, 11 into 2 plus 2 is 4. So 11 into 4 equal to 44. And again if we substitute n equal to 3, then we get third term A3, right? Then how to write this? 3n means 3 into 3 plus 5. And here 3 plus 2. Then 3 into 3, 9. 9 plus 5, 14 into 3 plus 2 is 5. So 14 into 5 means how much it is? 14 5 is 70. So that is the answer. Okay, now this is second question. I mean example number 2. Right, first 5 terms of the sequence defined by an equal to minus 1 whole power n minus 1 into 2 power n. In first question we found only first 3 terms. But here we'll find first 5 terms like A1, A2, A3, A4 and A5. Okay, very simple question. So first write the given value. What is that? Given that an equal to minus 1 whole power n minus 1 into 2 power n. For first term just substitute n equal to 1. Then we get A1. So it is minus 1 whole power 1 minus 1 into 2 power 1. And how to write this? Minus 1 whole power 0 into 2 power 1 means 2 only. Any value is power 0, that is equal to 1. That is minus 1 power 0 na, minus 10 power 0 na, 1 power 0 na. Either for positive or for negative value, power 0 is given. Power 0 is there. That is 1 now. So how to write this? 1 into 2. So 1 into 2 can be written as 2. And coming to second one, just substitute n equal to 2. Then we get a2. So how to write a2? Minus 1 whole power n minus 1 is 2 minus 1. And here 2 square. Minus 1 whole power 2 minus 1 is 1. Then 2 square means 4. But how much it is? Minus 1 power 1 is equal to minus 1. So minus 1 into 4 can be written as minus 4. That is the second term. And coming to third term, just substitute n equal to 3. Then a3 na. So minus 1 power 3 minus 1 into 2 power 3. So how much it is? Minus 1 whole power 3 minus 1 is 2. And that 2 cube means 2 into 2 into 2. That can be written as 8. So what is the value of minus 1 whole square? Minus 1 whole square can be written as 1. So 1 into 8 equal to 8. And for fourth term, substitute n equal to 4. Now it is here 4. So minus 1 whole power 4 minus 1 into 2 power 4. So minus 1 whole power 4 minus 1 is 3 into 2 power 4. 2 into 2 into 2 into 2 means 16. But what is the value of minus 1 whole cube? So minus 1 whole cube can be written as minus 1 into minus 1 into minus 1. Minus into minus plus, plus into minus, minus, right? 1 into 1 can be written as 1. See, minus 1 power odd number is there. We get minus 0. Minus 1 power even number is there. We get plus 1. So here it is minus 1, right? Into 16. So that can be written as minus 16. And this is the last one, right? If we substitute n equal to 5, then we get fifth term a5. So how to write this one? Minus 1 whole power 5 minus 1 into 2 power 5. So minus 1 whole power 5 minus 1 is 4. And what is the value of 2 power 5? 32, right? 2 power 4 is 16. 2 power 5 means 16 into 2, 32. Just now I told you minus 1 no power of a1 number. So we get plus 1. So it is 1 into 32. So 1 into 32 can be written as 32. So these are the first 5 terms of the given value. Okay, now this is the next question. That is question number 3. What is the 18th term of the sequence defined by an equal to numerator n into n minus 3, denominator n plus 4? Okay. So first write the given sequence an. What is that? An equal to n into n minus 3 divided by n plus 4. Now which term is required here? 18th term. So for 18th term, okay. For 18th term, put n equal to 18. So if n equal to 18, how to write this value? So here a 18 and it is 18. 18 minus 3 divide by again 18 plus 4. Now 18 into 18 minus 3 is 15, right? Divide by 18 plus 4, that is 22. And here 2 11s, 2 9s. Then what is the remaining value? 9 into 15 means 15 into 9, 135. And denominator value is 11. So that is the answer. Suppose if they will ask 20th term, then substitute n equal to 20. If you want 50th term, then substitute n equal to 50. So whatever it is required, which term is required, which term they are asking in that question, we have to substitute that respective value in the place of n in the given sequence. Clear? Now see this question. Question number 4. Example number 4. Let a sequence be defined by a1 equal to 3, an equal to 3 into an minus 1 plus 1 for all n greater than 1. Find the first 4 terms. So first four terms means already A1 is given. Okay. We find A2, A3, A4. Including this A1, those terms are first four terms, right? And what is the value of this one? Means a given value. A1 equal to 3. And the AN is 3 into AN minus 1 plus 1 for all n greater than 1. Means we can substitute 2, 3, 4 in the place of n. That is the meaning of n greater than 1. We can take more than 1. Okay. So now we want second term. For that substitute n equal to 2. A2. How to write it? 3. A2 minus 1. 10 plus 1. Now 2 minus 1 can be written as 1. So 3 into A1 plus 1. So 3 into, what is the value of A1? That is 3. So then plus 1. So 3 into 3, 9. 9 plus 1 equal to 10. At the next term, just substitute n equal to 3. So A3 equal to, so again 3 into A3 minus 1 plus 1. That is 3 into 3 minus 1 is 2. So 3 into A2 plus 1. So 3 into, what is the value of A2? That is 10. Just write here 10 plus 1. So 3 into 10 is 30 plus 1 equal to 31. And we want one more term. For that substitute n equal to 4. So A4. 3. A4 minus 1 plus 1. So 3. A3 plus 1. Now that can be written as 3 into, what's the value of A3? That is 31. Then plus 1. So 3 into 31 means 93 plus 1. That can be written as 94. 3 into 30, 90. 3 into 1, 3. 90 plus 3 is 93 plus 1 equal to 94. Therefore, the first four terms are, what is that first one? A1 value is 3. So A2 value is 10. A3 value is 31. And A4 value is 94. That is the answer. Okay. Now this is fifth question. Write first 5 terms of each of the following sequences of whose nth terms are. In that, this is the first sub question. What is the given value here? An equal to 3n plus 2. So now we write first 5 terms. So means A1, A2, A3, A4, A5. Okay. So now it is solution. First write the given term. What is that? Given that An equal to 3n plus 2. N equal to 1, we get first term A1. That can be written as 3 into 1 plus 2. So 3 into 1 is 3. 3 plus 2 equal to 5. And n equal to 2. We get second term. How to write it? 3 into 2 plus 2. So 3 into 2 is 6. 6 plus 2 equal to 8. Now n equal to 3. Then we get third term A3. How to write it? 3 into 3 plus 2. So 9 plus 2 equal to 11. And n equal to 4. That can be written as A4 means a fourth term. Then how to write this? 3n means 3 into 4 plus 2. So 3 4 is 12. 12 plus 2 equal to how much? 49. And n equal to 5. Then we get fifth term A5. Then 3 into 5 plus 2. So 15 plus 2 equal to 17. So therefore, the first 5 terms, right, are, what is the first term? 5. Then 8, then 11, then 14 and 17. That is the answer. Okay. Now this is second sub question. What is the given value here? An equal to, right here, given that okay, now this is the second sub question. An equal to 3 power n, right? So what is the given value? An equal to 3 power n. Again we write first 5 terms. If n equal to 1, we get a1 equal to 3 power 1 equal to 3. For n equal to 2, we get second term, that is 3 square. So 3 square means 3 into 3, that can be written as 9. So for n equal to 3, we get third term a3. So that is 3 cube. Na? So 3 cube means how much? 27. And for n equal to 4, we get fourth term a4. That is 3 power 4. So 3 square into 3 square, that is 9 into 9 is 81. And coming to last one, for that substitute n equal to 5. So we get a5, that is 3 power 5. So 3 power 5 means 3 power 4 into 3. 3 power 4 is 81. 81 into 3 how much? 243. So here that is 243. So now I am writing here. Therefore, the first 5 terms are, what is that first term? 3, then 9, then 27, then 81 and 243. That is the answer. Now this is the third sub question. What is the given value here? An equal to minus 1 whole power n into 2 power n. For first term we can substitute n equal to 1, right? So a1 means minus 1 whole power 1 into 2 power 1. Minus 1 whole power 1 is minus 1 only. So here it is minus 1. 2 power 1 means 2. Minus 1 into 2 equal to minus 2. And for second term, substitute n equal to 2. Then a2 equal to minus 1 whole square into 2 square root. So minus 1 whole square is 1. And 2 square means 4. So 1 into 4 equal to 4. And for third term, substitute n equal to 3. So a3 equal to minus 1 whole cube into 2 cube, right? So what is the value of minus 1 whole cube? In previous question I told you, minus 1 power odd number is given, is there, that is negative. So 3 is odd number, then we get minus 1 into 2 cube means 8. So that is minus 8. And if you substitute n equal to 4, we get fourth term, that is a4 equal to minus 1 whole power 4 into 2 power 4. Minus 1 power even number equal to plus 1. So it is 1 into 2 power 4 means 16. So 1 into 16 equal to 60. And this is the last one. So n equal to 5. So a5, right? Minus 1 whole power 5 into 2 power 5. So minus 1 power 5 means again minus 1 power odd number. Then we get minus 1. And 2 power 5 is 32. So minus 1 into 32 equal to minus 32. So therefore, the first 5 terms So 5 terms are, what is the first one? Minus 2, then 4, minus 8, 16 and minus 32. That is the answer.